we'll go back to the start. If everyone was like the start of geography, the start of how we know it's a globe, the Greeks always knew it was a globe. We're going to touch on a couple of fake Greeks and the father of fake Greeks, but just know that Ptolemy was one of the fake Greeks who was big on putting in place all the infrastructure for sphericity way back in history before it was needed, as a good old grand guy. We're also going to mention Eratosthenes and I think someone else, I forget, but we're going to go into his book a little bit, and thanks Eric for providing it to me. It was better than I ever could have hoped for. Everyone should read it. It is a good read. Here's an intro panel, and here's the same text over here represented. I'm just going to read it out. It's the only book on cartography to survive from the classical period, and simultaneously is one of the most influential scientific works of all time. What do you guys think of that first statement right there? That's the only book that we have, and it's the most influential one.
Okay, so this is the primary source for the mainstream narrative moving
Yes,
forward. Got it.
essentially, yes. And it's like the basis for other fake Greeks to even cite. So other fake Greeks cite this fake Greek. I mean, this real Greek so far. I didn't say it was fake yet. So literally, it's like the reference on how to gather data and draw maps. When we get into this, you guys aren't going to believe this shit, but Ptolemy championed the use of astronomical observation. Wait, what do you mean? He was the first one to look at the stars to measure the Earth. No way. The father of globularity. And then applied mathematics in determining geographical locations. Wait a second. Did he just invent astrogeodetics? Hold on. Gathered data to draw maps and championed the use of astronomical observation and applied mathematics in determining geographical locations. Yes. Yep, that's what that is. Okay, so they attributed astrogeodetics to him. He invented it right here, and it's the first page. Haven't even done anything. So, more important, introduced the practice of writing longitude and latitude for every feature drawn on a map so that someone else possessing his wonderful text and father of everything could reproduce Ptolemy's map at any time. What? Hold on a second. Ptolemy was in the ancient times writing about, this is ancient Greece with their fake long lat, and then longitude, as we know, wasn't invented until 1714 with the board of longitude and back 1702. So what is this guy doing with the birth of time and the father of history writing everything in geographic long lat? WTF, bro. That can't be real. Nope, 100% real. We're going to look right at it. But so into the preface of the geography book, right? Just know that if you want to read it, actually no complete copy exists. It's definitely real, but no one has the complete text. We have good translation of parts of it. That's cool, right? It does have an enormous list of names that other people seem to have cited, and that's cool. But it involved long lat. So I wonder how he did that. I wonder how that worked. I wonder what challenges that posed. I wonder how that's going to connect to what we're talking about. I wonder why it's so abstract, first of all. This is the basis of cartography. The book is called Geographia, right? The basis of geography. Take note, it's not called cosmographia, right? Because they want to make you know that actually the astronomical measurements aren't involved at all, except the guy was the father of inventing those same astronomical observations and putting them into his model to behold the terrestrial and celestial spheres, right? He puts it right in his book, actually, that you must believe that they are the terrestrial and the celestial spheres to make sense of his book. So what does he have in here? It is, again, a treatise on cartography, the only book on the subject to have survived. It has topography, some maps, extensive than any other, succinct rules of astronomy and other forms of data gathering. He himself says that he actually didn't do it. He had nothing to do with it. He stole most of it from this guy called Marinus of Tyre, right? So he cites this other guy who may or may not be real, or may or may not himself cite other fake Greeks. Who knows? I didn't go much further than that. But just know that Ptolemy, the father of all this, is actually saying that mostly he stole it from this guy, and no one knows if he's real or not. Anyway, we're going to go back to our boy Hipparchus, all right, who also invented all the things that we needed for longitude, and it had like 17 Nobel Prizes, but all of his work got burned. Trust us, bro, or something like that. But he had also reliable astronomical data for a handful of places. So what they're saying here is the only thing that limited their geographical prowess on the terrestrial sphere was their knowledge of the celestial sphere, because they didn't have all these astronomical observations. They said they were limited by their lack of astronomical data. Oh, man. Therefore, you couldn't make a map. you couldn't make a map of the ground because they didn't have astronomical data. I'm going to keep saying that. Like, that seems crazy, but that's how it was done. So why is he writing down longitude and latitude? And most importantly, is it real? Is this a real book? Well, it's a notorious parenthetic style of writing, meaning continually being suspended partway and interruptions and digressions completely later, repetition. If you're not prepared for Ptolemy's fondness for suspension and resumption, you might think that you're being led to its subjective text by extensive interpolations, or that Ptolemy didn't know his own mind, or that they mashed together a bunch of bullshit and called it this book. Anyway, is it real? In my opinion, as a legendary sage said, negative Ghost Rider. Is it real? No, full of shit. This is a whole 100% horse shit manufactured. Right? This is nonsense. Alan, this is the Ghost Rider for you. And this one also was a Ghost Rider, but I fucked it up.
Sorry, my mic was muted. I laughed really hard when you said that.
Nice. Negative Ghost Rider is my answer to is it real? Yeah. So here we go, right? This is like page 1. This is the terrestrial and celestial spheres. And it says, Ptolemy assumes that the reader understands and accepts the two-sphere model of the cosmos. That is, that there is a terrestrial and celestial spheres that are inextricably linked. And that, whoa, isn't it crazy that Ptolemy gave the definition of the celestial sphere from Wikipedia? That's weird. It's probably nothing. The stars are thought of as fixed to the surface of the outer sphere. Oh man, we just went over that. Anyway, if we read on a little bit, he assumes that the horizon divides the celestial sphere into 2 equal parts. He's already going back with his hardcore bisecting Great Meridian, right? To assume all these things and start making his geographic coordinates. Of course, he has to make a spherical coordinate system, which is how he started this, right? He had to know all of that to do this, which in 200 BC is questionable, but Wikipedia says he did it, so that's what we got. And he assumes that everyone is in the intermediate northern latitude so that he can make things, like the latitude is equal to Polaris elevation angle and other assumptions that simplify his calculations. But for the ancient geographers, geographical directions were always determined astronomically. Essentially, where's north? I don't know. Where's the North Star? Boom. That's as simple as it was. That's all they had. That's all it was. That's all that means. So everything in basis that we have was determined astronomically. Always has been. This has been my position so far. So far, pretty good evidence. Astrolabe, we got the armillary sphere, we got the Ptolemy, the father of all geography, has actually said, well, the terrestrial and celestial sphere must be combined. It is like if you're a heretic, if you don't understand it. Here's his explanation of longitude, latitude, which we also went over at the beginning. And he's defining a parallel of latitude. Now, this is a little bit different. There's a circle on the terrestrial sphere parallel to the equator, meaning that he can have a equal altitude angle, right? So anyone on that latitude has the same elevation angle. That's what he's talking about here. Kind of clever if it was real and if he did that. Another thing, he's seemed to be accessing Wikipedia, or Wikipedia is accessing Ptolemy. One of these things is true, but here's a picture from his graticule, as Ptolemy came up with a graticule way back when. Interesting. Of his second projection, which looks a lot like this projection and looks a lot like this projection, but is different. Don't worry. He invented these, 3,000 years before these, so don't worry. These are different. And this one shows the resulting graticule, which is a pseudo-conical projection. It just means that there's a variation on the other map projections. As we know, we have many map projections. If you go to the database page, there's several there, and what he had was a pseudo-conical, and we'll see, boy, that's not even a big deal. You got tangent, you got conical, you got pseudo-cylindrical, you got pseudo-conical, you got pseudo-cylindrical, you got pseudo-azimuthal, you got regular, you got partial ones, you have ones that take polyhedral things, retro-azimuthal. Doesn't matter. There's all sorts of projections of the celestial sphere onto the plane, and that is what all of these represent. When you're looking at these distortions from the tesseract matrix, these aren't distortions of how the globe Earth is disordered on a plane map. It's distortions of how the celestial sphere is portrayed on the planisphere, right? So the astrolabe did a better job than the globe Earth. But if we move on, in Ptolemy's book, oh look, Ptolemy had an armillary sphere. Guys, look at that. Isn't that crazy? Who'd have thunk it? And he didn't have an astrolabe. Nope, he's a big boy. He had the armillary sphere because Earth is a globe, and he knew it, right? That was the whole thing. I don't know if I buy that, but if we look at his book on what he did have, literal chapters and chapters and chapters and columns and pages of geographic long lat angles measurements. Crazy, crazy. Let's look at some. Like the whole book was this. Uh, it's just lists of towns, places, points of interest, and his version of long lat to help the lads in the future who were going to come down with the long lat later. He knew that you'd be able to convert his long lat to our long lat, but I wonder how that would happen though. I wonder how you would convert his measurement to our measurement. And we're still going, by the way. We're still in, like, this is like the third chapter of straight up GPS long lats. And the book father of geography and the father of the terrestrial and celestial spheres, Ptolemy. So, interesting trick, right? Is how do they use longitude? Well, equal to 5 on the parallel road. So they had a ratio of a great circle, and they used this quaternary measurement to break down measurements. So they knew that 40,000 stadia of latitude to 72,000 stadia of longitude. So they use this, and then you can say to convert it. So they used a ratio of this to do longitude, which, again, this whole thing is fake, but this is the story of how they had longitude before they had longitude because it was in stadia. If if you do the math here, right, you can just say that, oh, well, this is the whole measurement. You can just do the 360 ratio. You can get your conversion factor. You can say, well, stadia measurements are just in degrees, and then degrees equals stadia because I've defined a metric and a straight up equivalence. And then you can all day long convert degrees to long lat stadia, and it makes no difference. So it's like, wait a second. So someone could have invented a fake metric of stadia, converted modern measurements and coordinates to this fake metric, and mathematically, no one could tell. Is that what I'm saying? 100%. That's what I'm saying, and that's what I'm saying happened. Now, real quick, all of these fake Greeks and their history on Wikipedia are backed up by other fake Greeks, and in particular, a dude called Herodotus, who I actually read about a lot in my college class. I read about his style is crazy, right? Myth and legend gets mixed. That is what I remember of reading the so-called histories in classics, is that it's myth, legend, and history all mixed in one. Who can tell if that was a god or a hit? Like that's the history, right? Homer, the Odyssey, the Iliad, the Battle of all of these are stowed in myth and legend. But if you this is the father of history. That's his name and title. He wrote in myths and storytelling about gods and legends, but he's the father of history. Just pointing that out because this is the guy that backs up Eratosthenes, Hipparchus, and all the other fake Greeks that we were mentioning. However, I wonder what shape Herodotus thought the Earth was. Just kind of a fun fact. Seems that through all his histories and all the ways that he described things on his word of mouth and oratory transcriptions, he always described the Earth with edges and at the end of the world, and considered Earth to be a flat dish with defined edges, and literally inferred that the sun was east, and if you didn't, that you were a retard. Little quote, but that is what he said, right? Strongly held a flat Earth view. In fact, he made a map, and it looks a lot like this map. It looks a lot like an azimuthal equidistant North Polar projection on everything that he knew. But who's to say? Just to say that Hipparchus, the dude who backs up all the fake Greeks, actually knew that Earth wasn't a sphere and was definitely a flat earther by every historical record, and there's copious amounts of them because he is the historical record and he writes all the other ones, and they're filled with his flat earth mannerisms. Now, all of that to say, at the end of the day, what do we get from this? Well, we get a geographic graticule that is a carbon copy of the celestial sphere. Literally, this is a one-for-one copy. You can go on a map, but are you really on a map, or are you on a celestial sphere? Or are you on a terrestrial sphere? Or are you on none of these things because all of them are made up based on math and coordinate systems? That's a trick question. The answer is the last one. So essentially, when we're looking at stars over flat Earth and right ascension declination, declination will be the angle of the latitude that this appears to the observer, and then right ascension will be the time, right? We need the time component for when it appears at a ground position. It'll never change latitude, but it will rotate around the Earth and change at a ground position. So the final piece will be combining all this into, I think, a script. We're going to take an observation from Stellarium. We're going to plug in the azimuth and the altitude. That's it. And the program will show you where you are on the globe geographic graticule, because that's how inextricably linked they are. I can tell you based on a star where we are. Now, that wouldn't be possible unless everything I'm saying is true. Now, there's an inextricable link between the stars and the map, right? I call it between the celestial sphere and the geographic graticule, because latitude and longitude are inextricably linked to the sky and the stars and the time and sidereal time, right? You can look at a star. You can take an azimuth, meaning directions, 0 being north, and you take a 360-degree reading from there, and that's your azimuth. And then an elevation angle, which is just its angle of incidence above the horizon. If you take just an azimuth and elevation angle of any star, then we can tell you where you are on the graticule. So I put it into where I'm at, about, let's see, Massachusetts. Yeah, let's try here. Yeah, Massachusetts. And I'm going to look up. I'm going to find this star. I'm going to run my program on this altitude and elevation. So this is in, right ascension and declination, but let's convert that. Let's do quickly the program here. So we'll give it a run, and we'll say it's at 45-ish azimuth, and it's at 54-ish degrees. And today is at 9/24, so 2024. Was it months? So 9/22, and it's 2/13, 14/13. Now that gives us a plot of the ground position of the star that I just saw. So what that is giving us is this, right? So what it has, just by an azimuth and an elevation of a star, when I look a little bit north, so here it is, and it gives you the ground position on the graticule of where that star is. Now, the time is necessary because you will have to know when it's going to be over a certain point, like when that ground position is going to rotate depending on its latitude around the circle. Essentially, this dot is going to rotate around here. Depending on the time is when it's going to stop over here. So this is where I saw it. This is what the ground position is. This is where it is relative to me as I'm over here. And this is why there's such a link between the sky and the map, right? There's no one measuring the ground, mind you. We're just finding our position relative to the stars. And this, I think, should prove it. Right? As we just showed, at any point, one of these stars will give you the exact location where you are on the Earth. It doesn't have to be right ascension declination. There's a direct conversion happening for right ascension declination to long lat, right? So here's what it looks like on the AE map. Imagine the continents are here, right? If I drew them in here, then this would just rotate around and you would have the time when you would see the star. So here it is, right? And then here would be it moving. So just imagine, this is why the time is necessary. None of these stars ever change latitude. If a star appears at this latitude, it will appear at this latitude for everyone. The only thing that will change is the time, and the time gives you the position of the ground position of the star, which is why right ascension and declination and right angle hour ascension conversion are necessary, right? The stars are everything. The stars are the backbone of longitude, latitude, backbone of the grid. They're the backbone of everything. If we use the stars to measure the stars and then compare them to the stars, it's always going to come up stars, right?
Comes up stars.
This is essentially why it's important. This is what they've mapped out. All they've done is look at the sky, take a good map of it, and then they've given us the corresponding points on the ground. Now, because the sky is in a dome shape, we see it in a hemisphere. When you match the ground to it, what shape does that force the ground into? Of course, it would necessitate sphericity. So that's where, in my opinion, all sphericity comes from.
Yep, and that's pretty much it. That's the whole thing. Hour and a half, hour and 40 minutes. Not bad.
Hey, for that last part, what about the wobbles? Wouldn't the wobbles throw all that off?
Yeah, well, in flat Earth, the stars are the same forever in perpetuity, and we built pyramids to them, and they don't ever change. But in globe Earth, they pretend that's not the case, so I don't know how to handle that.